Hey everybody, this is Larry. This is me going Q3, off by one fingers. Of the bi-weekly contest 115, longest unequal adjacent groups subsequence 2. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. But this one is the same as Q2 except for there's two differences, or maybe three. One is that n is up to 1,000 now, which is a little bit annoying. Um, Groups can have more just different numbers, like more than 0 and 1, and then you have this Hamming distance thing, right? Almost a Hemingway distance, which would be very literally, literary. In any case, um, to be honest, I ended up spending 10 minutes about on this problem, but I should have. I don't know. I think this was also a sort of a poorly constructed constraints on Leetcode's part, just because if you look at constraint, it's n is equal to 1,000, and honestly, the way that I did it, it's going to be n choose 2, which means it's going to be like half a mil times 10, which is 5 million, which is a lot of operations for Python on Leetcode. So. Uh, I mean, I don't know. So, especially if you're doing other stuff with it, right? That's like the order. So that is something that I worry about. But where I guess like if I were to do it again, maybe I should have just immediately switched to Java or C++ and got it much quicker. Just wasn't really thinking today. Did a lot of hiking and such. But yeah, but the idea is just longest path in a DAG, right? Given that n is only 1,000, n squared is going to be good. The part is that you have to kind of check a few things, and that's pretty much it. So the longest path in a DAG is a classic dynamic programming problem, where basically, yeah, basically the kind of structure of that, even though the structure of that would be something like dp or maybe like for I made of n, dp is sub I is some base case, maybe one. Well, I guess nj goes up to I. If there's an edge, between I and j for something, then dp of I is equal to max of dp of I or dp of j plus 1, right? Meaning, and this is just like a way standard longest path in the DAG. Yeah, just word out of my head. But basically, if there's an edge, then you want to take it and see, or you want to see if taking it will give you the longest thing, right? So that's basically the core idea about this one. Yeah, and if you kind of look at this format, that's basically what I end up doing. I mean, this I kind of did it with words and group. So we'll go over it. Oh, and for this particular problem, you do need path reconstructions. You have to keep track of which path you take. That's so I guess that is a little bit of a kink on it, but you know. But I honestly just spend most of the time, and you can watch it on a live portion. Just try to figure out whether I want to do this or there's another way to do it, which the complexity is also up for counting. But maybe it'll be faster, but I wasn't sure um, because this one has a lot of. It's very sensitive to the input things, right? Because of the early terminations, which we'll go over in a sec. Yeah. So first of all, I actually don't think I used this. I think I was going to use this and I didn't. So I added some extra bonus waste of time. But yeah, but but here for each word, as we said, we look at every other previous word and then we see if there's an edge. And there's an edge if the groups are different, then there can be an edge but the length of the word is the same, and you have this good function. And the good function is, of course, just that delta has to be 0 or 1, meaning, or technically exactly 1, I suppose, actually, for this problem. But all the words are distinct, so it cannot be 0. So it has to be 1 if it matches. And then if this is all good, then we check to see if this is a better path. If this is, we set the best to that, and we set the prior thing to this p index. And then at the very end, we update it to the things, and then we update for the things globally. Yeah, and basically all contains the or BG these variables contains the longest subsequence, and or contains the index that the last index that contains the last node in that longest subsequence. And then here, just path reconstruction. You keep on going to the previous node that you kind of looked at, and then keep putting the answer. And of course, you have to convert it back because you went backwards. You have to reverse it again to kind of get the answer. Like I said, this is going to be n squared. But the tricky part is that the good function is alpha, or no, not alpha, length, where which is the max size of the length. So this is going to be O of n squared times L, right? And yeah, and that's pretty much it. That's not true. Not the space bar. Space were actually pretty cheap. We don't really do anything other than linear things. And I guess no, yeah, I guess the answer is also at most linear. So yeah, so linear space, and yeah. That's all I have with this one. Let me know what you think. I think the longest path in the DAG here, if you really want to solve Q3s, you really should, like, these should be gone down much quicker. And path reconstruction is a little bit on the tricky side, but I think once you do it, like, I don't know, 10, 15 problems of it, is you get the idea behind it anyway, so you should be able to solve it. Yeah, that's all I have for this one. Let me know what you think. And yeah, you can watch me solve it live in contest now. Hopefully this fixes it. I was just really silly on that one. Alright. Let's do Q3. Am I really slow? I think so. How are people doing in this contest in general? Oh, actually I'm not. I mean, okay, well, the timing is obviously just not right. But not that I'm behind, but not like, I don't even know how far I am behind actually, to be honest. How many people? Okay. I mean, I am definitely behind. People did it very quickly. But, all right, focus. Okay. Words and groups, hammering distance between two. Okay. So, okay. Longer subsequence such that they're not equal to. Okay, so the same as like before. Groups of I could be 1 to n, which is, I don't know why they kind of don't mention that in the last one. Hammering distance is 1 for JSON ones. Okay. Let's see. So n is 1,000. Is it just DP? Can we even do other things? 1,000 to previous 1,000 is going to be 500,000 times 10 is kind of silly to even just like having to construct this. But this is kind of annoying to do. It's not hard, it's just annoying. I mean, maybe it's also hard, I actually don't know. But it's just like, I feel like Python is very close on the running time, that's why. So it just becomes the longest path in the DAG, right? With path reconstruction. $26 times 1,000. I guess that's fine. Yeah, all right, fine. Is that really faster than? Is that true? 26 times each character. 26,000 times for each word. Oh no! Each word we do 10. 10 times 26. 260 operations for each. Times another 10. I think that's not even that much faster. I hate this, that they make the constraints so not Python friendly. Okay. Yeah. Okay, so then now, let's say for how do I do that? The groups thing is a little bit weird. I mean, it's not hard. It's just I'm just gonna do it naively, and then we'll see if Leetcode calls me out on being slow. It's not even that hard. It's just the constraints are so silly. Each one, link 10 characters, 20. So the distinct, so that's good actually. Which way is faster? Okay, fine. Alright, so now we just say lookup, right? The unique, so I just say this is that, and then now what we want to do is best, also kind of this, for word G and word subgroups, we want to say, okay, current best is equal to 1 for just having itself, right? And now for do they have different lengths, or do they all have the same? They all. They may have different. Oh, yeah, they may be unequal. Okay, that's fine. That's what I thought, but I was just wondering why you would do that, because I don't know. I guess I can actually construct it in 2 different ways. Right. This problem is just like really annoying to kind of keep it keep the complexity down. It's not even hard, or like not complexity, but just like edge case things. Yeah, okay. I'm just gonna go backwards. We'll see if this works. Actually, I have no idea. If groups P is not equal to groups of index, then and good P and index, then B is equal to max of B and best of P plus 1, and then best of index is equal to P, right? And then we just return max of best. But yeah, I spent a long time thinking about which one to go. I don't know how I feel about it, but yeah. Let's actually put this here. And length of P, width of P is equal to length of. It's a minor premature optimization, but this is actually index. Two is not. Oh, I have to do the reconstruction. That's why. Okay. I hate you. Let's see if we get 4 for the last one now. I'm so slow today. I don't know. Yeah, you said 2 and 4. I guess at least we got it right. And then now we have to reconstruct. Right. Oh, I guess we have to do a previous thing. Yeah, this is so annoying. Well, oh, it's not equal to -1, fine. Yeah, I have to do something like it's equal to previous. Okay, that is no great, no good, no Gucci. Okay, R is -1 for some reason. G should be should do something. I don't know why. Also miss having a laptop, but why would this not ever do anything? G, did I update G by accident? Oh, G is group. That is terrible, Larry. I don't know even remember why I did this, but that is just best overall. I don't even know why. What G stood for. But shadowing is kind of sad. Okay. So that's the index. We actually want to read the words. Bad dab. Is that at least right? Bad dab. Okay, that's actually right. Let's give it a submit. It might time out. Okay. I spent so long just because yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Kind of tricky one. Yeah, stay good, stay healthy, do your mental health. I'll see y'all later and take care. Bye bye.